Hello everybody, in this video we present our work Articulated Object Estimation in the Wild. The majority of works investigating articulated object estimation predicts kinematic models of objects from several frames representing various articulation states. In general, those objects are isolated from a greater environment and distractions or background noise are absent. While humans learn manipulation by observing others, we approach the problem of human-to-robot imitation and as such aim at enabling robots to perform the same articulated object interactions as demonstrated. However, we aim to do this in the wild, which means in non-curated settings under sensor noise and environment distractions, as well as dynamic camera motion. In this work, we propose RD-Point, a framework for estimating articulated object models from point trajectories. First, we make use of in-the-wild RGBD videos and employ an interaction prior by extracting hand masks that provide interaction segments across time. Second, we obtain point trajectories using any point trackers within regions close to the detected hand, which describe both the static and dynamic parts of the observed scene. Third, we lift those point trajectories into 3D using depth and compensate for camera motion. This enables us to estimate the motion of the moving part triggered through hand interaction. Finally, given the acquired point trajectories, we estimate the underlying articulation model, classify the joint type, and globally register the model in the observed scene. In order to properly evaluate our approach, we recorded the RT4D dataset, which, to the best of our knowledge, is the first egocentric in-the-wild human demonstration dataset capturing scene-level articulated object manipulation. With this dataset, we aim to create a foundation for studying the problem of circumstantial articulated object estimation. Different from previous datasets, in RT4D, the camera poses are dynamic, we face significant clutter and non-isolated objects, and we provide human demonstrations of 415 object interactions, temporal interaction segments, and we provide reconstructed scenes, including object access labels. The dataset spans 4 diverse environments, ranging from a robot lab to a kitchen scene, and contains various kinds of objects. Here we show the point trajectories that are obtained using RT-Point on a cabinet featuring a revolute joint and a slider shelf featuring a prismatic joint. As visualized, we are able to track the dynamic object part even under partial occlusions. Next, we show an entire scene and the predicted object axes that were estimated from human-object interactions. While RT-Point produces robust estimates overall, especially dark objects as well as semi-transparent objects prove to be challenging due to unreliable depth measurements. In this scene, we visualize the RGB camera inputs containing the human-object interactions on the left and show the predicted axes and object poses on the right. In terms of quantitative evaluation, RT-Point outperforms previous classical estimation frameworks as well as the learning-based method Ditto and RTGS, relying on Gaussian splatting. Overall, we observe the smallest angular errors for both prismatic as well as revolute joints and see the highest accuracy in predicting the actual joint type. To summarize, we make the following contributions. First, we provide a novel articulated object estimation framework that enables in-the-wild prediction of object articulation models. Second, we introduce RT4D as the first real-world, in-the-wild dataset of scene-level human articulated object interactions. Third, we make necessary comparisons against previous works and ablate key model components. And fourth, we make both RT-Point and RT4D publicly available. Thank you for your attention.